All right, these are notes on 9-4. We're solving polynomial equations in factored form. So polynomial many terms. And then in factored form is something that's new, and we're going to be talking about what factored form looks like. It actually is the form before you multiply them out, so that's kind of a good thing. All right, so roots, first of all, are the solutions of an equation in which one side is 0 and the other side is a product of polynomial factors. All right, so we have an equation, right? So we're going to look down at example 1. We have an equation. There's my equal sign. One side is 0, yes, and the other side is a product of polynomial factors. So what that means is the two things or three things or four things, however many, that I multiply together and it makes a polynomial. If I were to multiply those out using FOIL, I would have a polynomial. So these are polynomial factors, okay? And we have product because parentheses mean multiply. So this example 1 right here is dealing with this definition, and we're going to find the roots. We're going to find out what numbers equal to 0 when you plug them in for x. All right, another definition that we need to have for this section is vertical motion model. And the vertical motion model is a model that describes the height of a projectile. The height of a projectile. All right, a very important property is the zero product property. So they say let A and B be real numbers. If I know A times B is 0, then one of those two at least has to be 0. If two numbers multiplied together equal 0, then the A's got to be 0 or the B has to be 0. So we're going to use that idea to help us with example 1. One of these two factors has to be 0. So you can probably see what you'd have to plug in this one to have that equal 0. What number goes in for x? A 5, right? If this was 0, then we don't care what this is, it's going to equal 0. Or if this x was -4, -4 plus 4 is 0. 0 times anything is 0. So it's not always going to be that easy to see. So what we're going to do right now is we're going to work out the problem as if we didn't already see that we know that the answers for x are going to be 5 or -5. So what we do when we have a binomial being multiplied together set equal to 0 is we know that either this term equals 0 or this term equals 0. So we rewrite it with two separate, we don't need the parentheses anymore, and we have an or sign in between because one of the two is 0. Then we would do our opposite here to get x by itself. So x equals 5 or -4. Okay? We're using the zero product property, the one above. One of the two of those has to be 0. Okay? So the solutions, or otherwise known as the roots, so there's two names. The roots, or the solutions, are 5 and -4. Both of those will end up equaling 0. If I want to check this, I could first plug 5 in for x. So I'm going to take this original equation, and instead of writing x, I'm going to write 5. So it would be 5 minus 5 and 5 plus 4. 5 minus 5 is 0. 0 times 9 is 0, so it would check. Okay? Or I could plug -4 in, so it's -4 plus -5 and -4 plus 4. So that would be a -9 times 0, which is 0. It checks. Okay, so let's go over, and I want you to do checkpoint 1 and 2 right now. Pause the video and go ahead and do those. Okay, so for this one, I set them both equal to 0, the two factors. I get x by itself, and x ends up being -6 or +3. All right, in this one, it ends up being 8 and 5 are the solutions. So you could write it like this, x equals 8 or x equals 5. Or you could just say 5, 8, 5 and 8, any of the above are the solutions or are the roots. All right, flip back to example 2. We are going to factor out the greatest common monomial factor. Factoring out means you're pulling the problem backwards. Something multiplied together to make this. this was the answer, like we were doing in 9-1 to 9-3, and now we need to go backwards. So what do you see that is a greatest common factor of 16 and 40? The greatest one. 2 can go in there, but it's not the greatest. What's the greatest common factor? It's 8. Then you look at the variables, x and y. Are they in common? No. So they have no common factor. So the greatest common factor of these terms is 8. That's it, just an 8. And we're going to pull it out, and then we do division. So 16 divided by that 8 was 2, and the x is still there in the inside. The plus sign gets rewritten. 40 divided by 8 is 5, and the y is there. So we're going backwards from what we were doing in 9-1 to 9-3. FOIL this out in your mind, or distribute it in your mind. 8 times 2x, yep, 16x. 8 times 5y, yep, 40y. Okay? Now let's look at the next one, letter B. We have more than just one number that's in common in those two monomial terms. So 6 is the greatest common factor of 6 and 30. We can see that. But now look at, we have x squared and x to the third. There's 2 x's and there's 3 x's. So how many x's are in common? 2 of them. So x squared is the common part of the x's. We multiply those two together and it's 6x squared. So we can factor out a 6x squared. You have to factor out the greatest thing. What is 6 divided by 6? 1. What is x squared divided by x squared? 1. So that's like 1 times 1 there, or just 1. I have to hold the place. I can't just get rid of it. The plus sign goes in between. 30 divided by 6 is 5. X cubed divided by x squared would be like this. How many x's are left? Just 1x. If you didn't have the 1 there, when you multiplied it back out, you would have lost this first term. So make sure that you hold a place there if you factored out the whole monomial term. All right, so please go to the checkpoint now for 3 and 4, and you're going to factor out the greatest common monomial factor, and then come back and see how you did. Number 3 would have been 2. The only monomial factor that's common between those is 2. And you're left with 5x squared minus 12y squared. When you FOIL it or distribute it back out, it's the same thing. In this one, 3 and 8 have nothing in common, so it's t to the 4th. You're left with 3t squared plus 8. When you multiply it back out, it equals the original term. Okay, so we're going to take this to the last level here, which is solving the equation. So what we need to do is put the two pieces that you just learned together to solve the equation. So right now I have it equal to 0, and they're saying find the solutions. What can x be? The problem is I don't have a product right now, do I? I don't have two things being multiplied together. I have a plus sign. So what I need to do is I need to take out the greatest common monomial factor, and then I'll have some products that I can deal with. So what's common between 3x squared and 15x? The greatest common factor. It's 3x. What are you left with? Well, I factored out 3 divided by 3 was 1. X squared, I took out an x, so I'm left with x. Over here, 15 divided by 3 is 5. X divided by x is 1. If I distribute this back out, it equals that. Now I'm to the step that we learned earlier. I have two things being multiplied together. There could be parentheses here if I wanted, right? Two things are multiplied together. So one of these two items has to be 0. So either 3x is 0 or x plus 5 is 0. Now you solve to get x by itself. X is being multiplied by 3. What is the opposite? Divide. 0 divided by anything is 0. Over here, subtract 5. X is negative 5. So my solutions for example A are 0 and negative 5. X could be either one of those. All right, for part B, they've taken it, oops, I need to write in here, my solutions are 0 and negative 5. Okay, so for part B, they've taken it to another level. They're not even on the same side now. So the first thing I need to do is subtract 24b to get it to the other side. So I have 9b squared minus 24b equals 0. Now I'm equal to 0 so I can find the solutions. However, I don't have factors. So I need to factor out the common monomial factor. And to make notes of what we did right here, we subtracted 24b to each side. So what is the common monomial factor here? It's a 3b. What are you left with? 3b minus 8. Now I have two products, or a product of two monomial factors, actually a monomial and a binomial. So I can set them both equal to 0. So 3b equals 0, or 3b minus 8 equals 0. So this one is just divided by 3, which is 0. This one is a two-step equation, right? Plus 8 plus 8. So they didn't leave me any room for my work here. I'll just do it down here. Now I have 3b equals 8. Divide by 3. What does b equal? 8/3. So b is 8/3. So my solutions, or my roots, are 0 and 8/3. Each one of those makes me end up equaling 0. Okay, the last thing we need to talk about is the vertical motion model. So the vertical motion model you are going to see for the rest of the year, so you might as well start getting it in your brain now. Okay? The height, h in feet, of a projectile can be modeled by h for height equals negative 16 t squared plus vt plus s. So t stands for what? You know this. Time. In seconds, the object has been in the air. V is the initial, got to get that word, initial, so the starting, right? Initial vertical velocity. And it's in feet per second. That's the rate. And S is the initial, and this is the one that you got to kind of remember, height. It doesn't stand for seconds or anything else. It's the initial height, okay? So it says the vertical motion model takes into account the effect of gravity, but ignores other less significant factors such as air resistance. So we're going to use the vertical motion model here to solve the next equation. So example 4. A fountain sprays water in the air with initial vertical velocity of 20 feet per second. After how many seconds does it land on the ground? So you need to start with the vertical motion model, which is that equation that we just were given. Then you need to find out any information that they gave you. So V stands for initial vertical velocity, which is 20 feet per second. So V is 20. And this one is hidden right now. Initial height. What is the initial height? A fountain sprays water in the air. Well, where is it basically then before it starts spraying? It's at 0. It hasn't gone up in the air yet. So the initial height is 0. And for right now, all of our initial heights, little clue, are going to be 0. So we can ditch the plus 0, and we have height equals negative 16t squared plus 20t. Okay? So now we want to know after how many seconds does it land on the ground. So h is your final height. So we are going to substitute 0 for h, because what's happening here, we've got our fountain spraying our water, right? There's our fountain. Here, I don't know what kind of fountain we have. There we go. There's our fountain spraying water. Okay, I guess I should have made it flush with the ground, so we'll pretend this is underground. So here's my ground. It's starting at 0, it goes up in the air, and then it's hitting down at 0 again. So we substitute 0 for h. When the water lands, its height above the ground is 0 feet above the ground. It's back on the ground. Okay? So then we solve our equation we just learned up there for 0. So we substituted 0 for h, and now we solve. So it's just what we were doing before. Pull out the greatest common factor. It's a 4t. We're not even worrying about that negative sign. Just leave it in there. So that's a negative 4t plus 5. And now I have two things that I can set equal to 0. Either 4t is 0 or negative 4t plus 5 equals 0. So t equals 0, or subtract 5 to both sides. You get negative 4t equals negative 5. Divide by negative 4. T is a positive 5/4. Positive 5/4 when I solve that two-step equation. All right, well, which one makes sense? After 0 seconds, could the water go up in the air and then land back down on the ground? No. So this one's not realistic for real world. The only one is 5/4 seconds. And you're not going to say 5/4 seconds, will you? You'll say 1 1/4 seconds or 1.25 seconds. Okay, so pause the video, and you're going to try 5 and 6, and then I'll also do 7 with you, or you can try it on your own if you think you're ready. Okay, so for this one, d equals 0 or d equals 7. And in number 6, it's 0 1/4. Did you make sure that you had 4b minus 1 there when you factored out the 2b? That's one thing you want to make sure. Okay, so the last one, it says, in example 4, suppose the initial vertical velocity is 18 feet per second. How many seconds does the water land on the ground? So it's the same idea. Here's your original equation. It's plus VT, but now it's 18 instead of 20. And it's still plus 0. My initial height is still 0. So now I'm going to substitute 0 in for h and see how long it takes for it to land back on the ground. My common factor that I can factor out is a 2t, and I'm left with negative 8t plus 9. Set them both equal to 0. Divide by 2 over here. T is 0, which, we already know it's not going to be 0, right? Or, oops, a 9 there. Negative 8t equals negative 9. So T equals 9/8 seconds, which will divide out, and it's going to be 1.125 seconds. All right, great job. Those are your notes. Continue to the next step.